Hey guys, so in this video we're gonna talk about indefinite integral. And indefinite integral is basically, it has various applications to it in calculus. And one of the best examples of, or I guess terminologies of integrals are, it is basically an inverse operations of derivative. So if that's the case, if we are going to differentiate a function, say f of x, f of x, and the derivative of that is going to be equal to f prime of x. But if we are going to integrate that f prime of x, it's gonna revert back into f of x. So in an indefinite integral, we have this symbol here, and this symbol looks like this. And basically, if we are going to integrate the function, this is the equation for it. So f of x is equal to the integral of f of x dx. I'll make it a big f of x. Okay. What does this mean is that another applications of integrals is basically finding the area under the curve, which is called definite integral. So I will actually explain the meaning behind this equation of dx and f of x, because this has a big applications into an area under the curve, which is called definite integral. But in this video, I'm just gonna propose to you guys some basic principles of integration, and that if we are going to integrate, say, some polynomial function, for example, if we have f of x is equal to x squared plus 5x plus 6, if we are going to differentiate this function, we will have f prime of x equals to 2x plus 5. Now, in this case, if we are going to integrate this particular function, the solution will revert back into this original function. And I'll prove you why. So, for instance, the equation for the basic integration function is this. So f of x is equal to x to the power of n plus 1 over n plus 1, where n is an integer. And if we are going to integrate this function here, as to which we just differentiated earlier on, we are going to have, see, if we are going to differentiate this, this will become 2x, and it's going to be 1 plus 1 over 1 plus 1 plus 5, and by the way, x to the power of 0 is equal to some constant. In this case, this is 1 or 5, I guess, and it's going to be x 0 plus 1 over 0 plus 1. And that's going to give us f of x equals to x squared plus 5x. And note that for every time that you are going to differentiate a function, you're going to have this constant c. And this constant c, by the way, this is a constant. This constant c can be any value. So in this case, this c can be 6 here, which makes this similar to the original function, which is this one. There are actually several types of integrals, and one of them is called integration by U-substitution. The other one is called the integration by parts, which is by far the most hardest part of integration. And the other one is integration by partial fractions. So where you are going to integrate a rational function, and the list will go on from there. But we are only going to tackle some basic principles of integrations, which involves only a polynomial function. So let's make some examples here. So say if we have this particular function f of x equals to x 1/2 plus x plus 5, and if we are going to integrate this function here with respect to x, and note that the equation is stated to be f of x is equal to x to the power of n plus 1 over n plus 1, provided that n is an integer. We are going to have big F of x is equal to x to the power of 1/2 plus 1 over 1/2 plus 1 plus x to the power of 1 plus 1 over 1 plus 1 plus 5x. And don't forget this constant c. And if we are going to simplify these particular expressions of algebra, we're gonna have a big F of x equals to x 3/2 over 1/2. I guess that's gonna be 2 in a sense. So there's gonna be 2 times x to the power of 3/2 plus 1 plus 1 is going to be 2, so x squared over 2 plus 5x plus c, and c is a constant. C is constant, and it can be any number. So thank you guys for watching, and I'm gonna make more examples of this in the near future, and also more examples on different kinds of integration of calculus. And yeah, enjoy your day.